All right, Lab 23. So let's go ahead and start implementing Lab 23 as a class. How about that? Hey, in case you didn't see this coming, we're going to do everything we did in the last class, but with an adjacency list.
Thank you for helping us.
Except for this time, instead of Dijkstra's algorithm, we're going to run Prim's algorithm, which we'll get to in a little while after we've coded some things, because, wow, we haven't used much class time talking about this. All right, so Lab 23, resource. Hey, let's see if we can make it. Nope. Fail boat.
You broke it.
I totally broke it. All right. So, oh wait, did I actually commit code from last time? Oh, that'd be cool. No, I didn't. I just added some extra functions. Good, we'll just get rid of these functions. Whee! There it is. Okay. All right, so class to begin filling out the private section of the graph adjacency list. What is the adjacency list graph going to be composed of?
It's going to be a vector or a list.
Vector of list. All right, start typing that out. I know at least one of y'all's connected because we got dots down here.
Not me.
I've always tried to find that person.
I got dots.
You get dots?
Yeah.
Oh, so it's not you.
For once.
Shut up.
Wow. Woo.
You've been all day. I don't need you.
Ooh, she doesn't need you anymore, Brian. Okay, wait a minute.
I never needed him, but you know.
All right. Wow.
You say that, but I balance out your chaos
No,
with
you
my
don't.
chaos.
No, you don't.
What?
You're more chaotic than I am.
Haha, no. Incorrect fake news.
Fake news, fake news, fake news. That's still my favorite Babylon Bee when the last election. No, never mind.
You will try.
Who did it?
Who did it?
Who broke it?
I just connected, don't worry.
Did you know you can also zoom in so we don't have to see the dots?
How do you zoom in?
You go to view,
Where's view?
the top of the terminal.
I don't have that.
What?
Yo. I don't have any borders or.
Control plus plus.
That did not do it.
That's what it
That's
says.
a plus K.
Whoever was typing, Amber betrayed you through me.
Sabotaged.
Yep.
Whoops.
All right, then what's going to be in this list? We need a
Numbers.
what? Not just, well, that's the weight, but we need, what else do we need? Let's look at our board. We need a node class. Let's create a node class.
Real quick, let's.
Now we,
That's the arrangement?
no, what would the node contain? What would the node contain?
Nodes.
Destination? Yeah. All right, so we can create our own node class, or we can use the STL's pair class. Which would y'all prefer?
What's easier? What?
I almost like to create.
Again, back to that conversation, how do you define hard and easy?
Are you talking about a pair class?
Yes, pair class.
I've never heard of this.
Oh, there's a C++ pair class. And that's like
Like
two
the
things
apples
together,
pair?
not like
Oh.
the opposite of orange or something.
That's what I was thinking of.
What?
I don't think a pair is the opposite, but it's okay.
I don't think like an apple would be an opposite. No?
Well, that's just because you're used to the apples and oranges, and I'm trying to fight that.
Well, I don't like pears. I like apples.
You like pears, but you don't like apples?
No, I like apples and oranges. I don't like
I
pears.
love pears. I like Asian pears.
The difference between Asian pears and American pears.
Yes. Asian pears taste almost like apples.
Whew.
You good pear?
I was waiting for some really awful racist comment.
Are they good at math?
Oh, okay, there we go. There it is. There it is. Okay, we all
Just
saw
like
it coming.
Smarties, I do not think an Asian pear helps you in any way toward your academics.
Smarties.
Smarties. If only.
And the
If only, I would be-
I would eat so
All
many
the
freaking
time.
pears.
I thought you were gonna say Asian. All right, so there's a pear class. So you can template it on the two types you want the pairs to have. And the first type will be, first is the first one, and second is the second. Whoa. So if you want to use that, what would we do? STD pair of, what are we going to store?
Weight and a node.
All right, so we'll do weight and the node, which is an integer, and then we close it, close it, close it. Wow, that was a lot.
Yay.
And we'll call it, what do you want to call this thing? Someone type it in.
The name of the vector.
Graph? All right.
Life, that works too.
Life.
Well, that's what ours looks like.
Well,
so.
we need to have a better name. Life is part. Oh, I see what you mean. It's the
Yeah.
graph of life. No, but this is This is going to represent any graph. So when we go to test, we'll create the life graph.
A list.
I like that one.
Ask a simple question.
How about a graph?
All right, we can do that.
A graph. What about a life?
A life. All right, there we go. Graph. Let's see if that compiles.
The answer is no.
World may never know.
We're missing-
Whoa!
I think we're probably missing an algorithm.
We're probably missing a test. Oh, excuse me. Hey, wait. Do we have any tests? Where have I?
Maybe.
Oh, we have a simple AL test. Oh, I've already written a test. Wow. Look at that.
Yay.
Creates a graph. We call it gal. What? Add from 0 to 4, weight 100. Assert that it is 100, then remove it and assert it's -1. Beautiful. Okay. Then we depth first traversal afterwards. Sweet. Okay. So let's see. Can we make the simple AL test? Undefined reference to depth first search. Well,
We haven't done it.
yeah. Let's go and just comment that out. Oh, we got some of them. All right, good. All right, so we got that graph. Now we need to implement it.
Yeah, now we gotta actually do the thing.
Do the thing.
All right. So graph AL. What do we call it? A graph? We're going to pass in the number of vertices we want. How do we make what's the graph again? It's a,
List of pairs.
almost, it's a vector of list of pairs. So what do we need to do to the vector? To make it have some number of nodes?
Oh.
Yes. Resize, all right.
Resize it first.
Yes, that's what we need to do. All right. Semicolon. Great. Let's see if that actually works. Whoops, that's not what I meant to do. Oh, good. I used to make a compilation error, but no longer. All right. Hey, let's just go straight to adding some edges.
We already have. Hold on. No, that would be like, I don't know what I'm trying to say. So we have nothing in the graph right now.
Correct.
So we need to go to find the start position
Which would be
on the
0.
original vector, and then input on
I actually think
the
starts
linked list.
Mhm.
starts the
end point.
vertex. End is the node it's pointing to, and weight is the weight of the movement.
Correct.
Oh, well that's actually fairly simple. I think.
See, it's fairly simple.
Why are we forward?
Let's go through the vector.
No, start is the vector we're accessing.
I mean,
End
no,
is
start
we
is
can
the
access
position in the vector.
position.
That's what he means to say.
Start is position, end is the node we're going to, and weight is the weight of the movement.
Sub.
Oh.
One sub.
What?
I don't know what's going on.
Who? What? The set. Wait a minute.
Discard. Yes.
What was the other person trying to type?
Vector.
Why?
Discard.
All right, so we jump to the position for. That's
No.
maybe you jump to
Although-
2, so now you have this list. So that's where you are now. Now what do we do?
I'll be entirely honest, I'm not entirely sure how we add.
So it's a list, right? So you can dot push front,
Huh.
and then what are you pushing?
The weight and the
Which is a
End and weight.
a pair. Hold on. Let me show you how this is done because
Yeah.
it's a little weird.
And would we want to push front or would we want to push back?
Doesn't matter.
Okay.
No, I'm asking. Doesn't matter.
Oh, he said doesn't.
I don't think
I
it
mean,
does.
I guess it just depends on the way you.
As long as you're consistent on how you access stuff.
Well, I don't think it matters because you're at the. No, it doesn't matter.
'Cause, I mean,
Does
way
the
we
order
did
of
it
the
looks like
edges
pushback.
matter?
No.
No.
No. And if stack and a queue, the order matters. And if sorted list, it matters. But we don't have any of that going on. We're just maintaining a standard list. So we don't care. All right. Let's see if that was it. Missing template, right? Because the pair has to be templated. I told you this part. I told you this was weird. Okay.
Yeah.
So now let me read this whole line so I can unpack it for you. So we go to our graph. We jump to the list. Jump to the list. We say to the list we want to push to the front. And what is the list composed of? Well, the list is composed of an STD pair of weights and integers. So that's why I have to specifically say STD pair, weight and integer, calling constructor. So that's going to create this pair on the stack in order to pass it to the push front function. And in the constructor for this pair, we're going to pass the weight and the end, which is passed into the function itself. If it's easier, you could think of it this way. If that makes it any easier. It's the same thing. Let me go ahead and compile it just to make sure. Good. All right. So we need to find out if two nodes are adjacent. Go for it.
I notice it returns weight. That's interesting.
What's that?
I notice it returns weight. It's interesting.
Yeah, because that's the weight of the adjacent. And just return -1 on the failure. That'll make life easier.
So,
I see now.
are we checking to make sure start can go to end? Or are we
Yes.
seeing if start can go to end or if end can go to start?
No, start, go to end.
Oh, okay.
this might be good.
Because so far I've only done directed graphs. You'll go into undirected graphs later, but from every time I use a graph, it's been always directed.
I think we need a for loop.
That's what I'm
Yes, we
thinking.
do.
Let's have a for loop. A graph, start what size.
Use an iterator. I'll get you started. For auto I equals, there we go. Is it dot begin? Oh, there we go. Because I'll tell you right now, if you try and type out what I's type is, it's going to be a nightmare.
Yeah, let's just save ourselves the trouble.
Hmm?
Yeah, let's just save ourselves the trouble.
It
So
really
let's use
is.
auto.
It's amazing how much of a debate auto was for C++.
Well, I was gonna just use int I equals 0.
But you can't do a get on a list. There's no
But you can-
subscript.
But you can grab the current size of the list.
You can get the size and you can iterate from 0 to the size, but you can't get list sub 1 or list sub 2.
Fair enough.
So, but we use an iterator, start at I at begin, and we keep going until I is.
Alright, I'm taking my hands off it.
Look at all of these USB keys. Everywhere. And that'll be not equal to end.
What? Oh.
So I is now pointing to the pair. And a pair has member variables first and second, and these are public member variables. And we had dot first is the weight, I believe, and dot second is the destination.
Yeah, so we're trying to track the second value.
I don't think that works.
It makes it what?
Right. If almost. Let me help you out real quick.
Nice. Could we also dereference it?
That's what the arrow does.
Yeah, but could we also do it with the
The star dot, sure.
yeah?
All right, let's see if that works. Ooh, almost. Maybe not. It compiled. So we add edge from 0 to 4, and then we try to go from 0 to 4, but we failed. So that's the weight, and that's the end. I wonder what it's trying to do. Let's find out. Let's see. We have an edge going to going to 4, and then we don't return anything. We have an edge going to 4, we have an edge going to 4. Huh. Weight equals. Weight equals 100. Edge going to 4. Ooh, why are we failing? Ooh.
The tests are wrong.
The tests are wrong.
That's always the answer.
Maybe.
If something goes wrong, you blame everything but yourself.
Right, everything but yourself. Who does that?
Me.
All right. Oh, silly C++ and your C out. All right, so start 0, end is 4, and then, well, it's in there. If second equals end, why is that not working?
See how that.
Maybe it is the test. Found. Are the tests really?
Apparently not.
Oh, because we don't remove.
Oh.
Ah.
It is the test.
No.
Technically.
It's us, not. We haven't done remove edge. Or remove vertex, sorry. No, not remove vertex.
Remove edge.
Remove the edge.
Isn't that the same thing as add, but you just pop?
Yep, same thing but reverse.
All right,
Well,
so
it's not pop.
the adjacent's probably working. Now we need to remove it.
It's pop's from
Well, actually,
that.
hold on. Before we say that, let's jump over and get rid of the remove test. Do we pass? We passed. So our adjacent is working. Now our remove edge is failing. So now we need to type in the remove edge. All right, let's do remove edge.
I hate this.
I'm sure it hates you too.
I don't like that.
You don't like them. It's just because you don't know how to use it yet.
It's been like 11 weeks. What do
Look.
you use?
Sublime.
What? Okay.
Use Adam.
I use Vim, so.
At least she doesn't use Emacs.
That was the big, super customizable one that you talked about at the beginning of the year.
Mm-hmm.
The one where you equated it with like,
A tank with, what was
A
it,
tank with
10
12.
cannons on top?
yeah, it's like a massive artillery gun.
For when you really need to destroy that spider.
Dear grid coordinates.
I just use Windex bugs. That way I don't get bugs.
Wait, you just put Windex on him?
Yeah.
That doesn't
It
kill.
does something.
It does.
It does kill him? Huh. I've never tried that. Hmm.
Reminds me of a meme I saw with Saruman. It's like there's a spider in your room. It comes closer. So you have chosen death.
I feel like we need a loop. Yes. Okay.
In this situation, your feelings do not betray you.
Let's just make it exactly.
I never go with my first plan when it comes to keys because my first plan's always wrong. Sometimes the second one is too.
I was waiting for that.
Oh yeah, like all your plans work.
Aw, that's a good bit. Huh. It's just coming down. I'm just scared of it.
Wait, which drink is that, Mark?
Pepsi.
Pepsi? This is a
caramel color.
Pepsi campus?
Yeah. Yeah. They don't have any Coke anywhere.
Oh, that's awful.
Yeah.
I prefer Pepsi.
Can you taste the difference?
Yeah?
You
Oh.
can.
Screws my throat, so.
Especially the diet one.
What? There's a big difference.
Yeah, there's a huge difference.
That's why I drink Dr. Pepper instead.
The diet drinks are.
Wait, they have Dr. Pepper here?
Yeah, it's
Yeah.
about right.
Oh, is Dr. Pepper not associated with Coke or Pepsi?
It's with
I think
Pepsi.
it's with both because at Chick-fil-A they have it.
Huh.
Oh, yeah.
They've got Chick-fil-A. Well, obviously.
Yeah, 'cause well, this one is, they have to have Pepsi.
Yeah. Dr. Pepper's just good.
It is good.
Dr. Pepper is a Dr. Pepper product.
Nice.
No, I really think it is, because it says on here this is a Dr. Pepper product.
Oh, okay. Oh yeah, the Dr. Pepper Museum. That one's in Waco, right?
Yeah.
I can tell you.
I'm trying to help you out if the webpage will ever load. Amber.
I'm trying.
Bum 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 ba-dun, do, 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 do,
It's owned by Pepsi.
What?
Bum.
It's owned by both.
Oh,
After their buyouts of their
well, that's beautiful. Wait, when was the bought out?
It doesn't say when. It just
They
says
have
that
joint
after their
custody.
buyouts of
That's
their
great.
fathers, it's part of them.
I'm glad that both of them own it. That way I can always
They
get
have
Dr.
joint
Pepper.
custody over the Dr. Pepper child.
Was there a trial? Hey, look, you have a dot erase function where you pass the iterator and it just erases it from the list for you.
Oh.
Did I do it right then?
No.
That's the iterator though.
No, you pass the iterator to the erase function like that.
Oh, like for the one.
It needs to say page graph.
Yeah, go ahead, fix it.
You should have told me.
That's why.
Right.
What is that?
Jacob's got it.
Oh, Greg.
Pepper packet. It's either way.
All right. And then what do you return? I'll let you type it because I'm lazy. All right. Look, look at all this work I've done for you. Look at all this work.
She's hungry.
You're not very appreciative of the situation. Hooray, we passed. All right.
We did it.
So let's see what else we have left. We need to be able to add some vertices. What do you think you need to do in order to add some vertices?
Resize the list.
Yep, you just resize the list. Okay.
Oh, wow.
Yeah, that was easier. How about removing a vertex?
Resize
Resize
the
the
list.
list.
You gotta delete
Well, we
that.
got to
And then-
delete that index, shift everything up, and then fix all the edges underneath it.
But if it's the last one, we're fine.
I guess you could always be an optimist.
No, no, this time.
Not in this class. Good call. Good call.
And then do we have to also delete every instance if it's like 0 went to 6 and then we deleted 6?
delete 4, we have to delete this edge because 4 is
Oh.
gone, right?
Mhm.
Oh no.
Oh no. And then anything going to 5, like this guy, needs to be updated to 4 because 5 has been shifted up.
Or we could just
Oh, no.
not shift it.
Yeah, we could just leave a hole and then just insert it that place.
Okay,
next.
sure. You could. Yeah, I guess you could not shift it. That would work.
Yeah.
Yeah, that might work. Tell me if that passes the test cases. Then I'll have to update them for next con. All right. Now where were we? Okay, so we talked about removing, adding edge, remove the edge. You have depth first, traversal, breadth first. We did adjacent. All right, so which traversal would you like for me to do?
Which one did we do last time?
Depth.
Let's do breadth.
Yeah.
Okay.
Do the opposite.
Do the opposite.
It's all for the day.
I'm sure they can't look that much different between the two.
They
Don't
can.
say that.
No. Between the two different types of things from last lab to this lab.
Oh.
They can't look that different, I don't think. They should look pretty similar.
All right.
Hope so.
It would be unfortunate.
So I will hope to God that you won. For the sake of my own sanity.
So we gotta use a cue, right?
Still a
Yes.
little left.
No.
Remnants
What's it going to be a queue of?
paper time.
Nodes.
Vertices. To visit. It's going to be empty. And then we're going to have a set of visited. And then we're going to populate the queue. I always forget the term for this one. Ooh, Star City Games. Queue. Y'all know the place?
What?
Y'all know Star City Games? I'll have to do that later. Really? No Magic the Gathering players?
I played a lot of Magic the Gathering.
You do? You ever been to Star City Games?
No. What is that?
Wow, that's probably the biggest online seller of Magic cards and
I used to get my stuff off like Amazon. Just
Amazon. TCG Player will give you some really cheap deals on singles. And you play as well?
Yeah, I just started getting some cards from them.
Oh, well, you
It
should
also
come to my
gets
office.
Walmart.
Just tell me next time you bring a deck and we'll play just randomly. That'd be great. What was I doing?
I had an Eldrazi deck for a while.
Ah.
We can
Oh.
talk
Really
about
good.
that at ACM tonight.
Oh yeah, have a Magic the Gathering tournament for
Yeah.
ACM. Ooh, that'd be fun.
Yeah, instead of always doing Smash.
Well, if Ethan showed up, he would destroy all of us.
I think we should do
I
Mario
haven't
Kart.
played in months, but it's fine.
Mario Kart would cause some big fights, man.
I have,
Mario Kart always causes fights.
I do actually have all the dual decks.
Ruin friendships, man.
So, if you want to do the dual decks matchup, that might be a lot of fun. But the most fun is Commander. If y'all know that one.
See, I haven't done Commander. Wait,
Commander,
have I?
that's where you have
It's
a
still
command.
small one,
All right, hold on. Let's get to this in a moment. Let me finish this up.
Okay.
Then we'll go back to it. Sorry about that, people in the front. All right, so we got push back and push. Okay, so we got to push the back. Got push back. We need to do our start node. We'll start at 0 just for the time being. And while
We
two,
always start at 0.
yep, just for the time being, to visit, and I think there's an empty function. Yeah. So while it's not empty, we're going to get the vertex will equal to visit dot, was it pop? Right?
I think so.
Pop front. All right, let's let me just compile, make sure things are working. Not yet. Has no member push back. Did I do Q? Oh, it's just push and pop. Okay. And it's not pop, it's actually, you want to do top, I believe.
Todd,
And then to visit dot pop, because they're two separate functions.
what about the first?
And then this one's just push. And I'm pretty sure that's what they want. Let me go and set this up so it's calling the correct function. Almost. No member top.
What do you mean pop?
Hold on.
First, front.
Pop, remove the next element.
Front.
Front, access the next element. You are correct. So it's actually front. There. Well, it ran. Anyways.
Nice.
Nice. Okay. If vertex, or I should do this, if two, wrong one, sorry, visited dot, what's the contains? Oh, that's set. Find, that's what it is. Find does not equal visited dot end. If we have already visited, then continue the loop. It just pops right back up to the top of the loop. Otherwise, we need to go ahead and visit it. So we'll call visit on the node, and that's the vertex. Then we'll do visited dot is it add or insert. Insert. All right, let me make that just to make sure we're doing fine so far. Nope. Woo. Oh, because in find we didn't pass it anything. Let's try it now.
What do you want me to look for?
What I want you to look for. All right, good. I'm at 0. Perfect. Okay. Then what do we need to do? We visited it. We've marked it as visited. Now we need to.
Return. No, we're not returning.
This is a breadth first. Remember, the queue is the set of nodes we need to visit next. We've confirmed that we need to visit this node, so we visited it. We've marked it as visited. What do we need to add to the queue?
We need to go through
The queue. Through the, sorry.
the list.
The list, right. Okay, hang on. There we go. And we need to go to visit, is it push? Push. And it's first? Which one? No, first, it's second. Because first was the weight, right? Yeah, first is the weight. Let me show you. First is the weight, second is the destination. So we add all those, and then we exit. Hey, that might be most of it. Almost. It's not graph.start. It's the vertex we're currently evaluating.
Vertex T.
Vertex T, vertex. Hey, look at all that. We're almost done. We have to, unfortunately, wrap this in a loop because we have to make sure we visit everything. So a graph dot,
Size.
is it size?
Well, then we can resize it so with the size. we-
Sure.
right?
Sure, why not? And that way it's going to try each one of them. There it is. Perfect. Let me go ahead and tap this out and give some comments. Make sure we visit each node
Visite.
starting at 0. Visite. Let me go 1, 2, 3, 4. There we go. And then breadth first search. There it is. And of course, it's keeping track of if we've already visited or not. Okay, I think that does it. All right, so that was the breadth first. Any questions on the breadth first? The depth first and breadth first are very important algorithms. Please make sure you understand these. They're going to help you a lot more, especially when you go into algorithms or other parts of your life, actually. These will pop up. Obviously, they don't pop up as often as writing a simple for loop to iterate through a list, but they do pop up many times. Oh, that's always going somewhere.
Maybe.
Maybe. Ooh, what are we doing?
Screenshots.
Screenshots?
When you post the code,
I gotta double check. I'm good now.
Okay. Let's see. Warning, add edge is not correct, but that's okay.
it's not.
Nope.
Why not?
I'll let you think about that.
Okay, is the commented part correct?
No, he said they're the same.
The two are the same.
Yeah.
It's okay.